Hello everyone, my name is Yansen Theopilus from Parahyangan Catholic University. Today I want to present you about my research entitled Development of Low-Cost Multi-Input Automated Storage and Retrieval System for Educational Purpose. Here's the outline of my presentation. Entering the Industrial Revolution 4.0, companies in various industrial sectors try to apply various technologies to their process and product. The technology which is used in various industrial sectors to improve efficiency and productivity is the automations of production and distribution system. As we know, automation is a technology used to carry out various processes or procedures with little or no human assistance. The rapid development of automation technology makes the world of education should quickly adapt and educate the development of the technology to its students. Nowadays, learning about automation technology in higher education is very important. The implementation of this learning should be supported by the ability and readiness of the lecturers, appropriate learning methods, and good facilities. Unfortunately, the challenges that often arise for developing countries are the very expensive automation learning tools and limited space for the procurement. In some universities that have limitations, students just can learn a variety of automation technologies from slideshows or learning videos without being able to practice more. This phenomenon makes the students cannot practice what they have learned, so that they don't have the skills they should have in the workplace. In the long run, it will cause a big gap in the quality upgrade rate because the students of poor university never have an adequate practice learning to prepare their students for the workplace demands. This matter is a poor phenomenon in recent education system in many developing countries. Therefore, the solution we propose is developing low-cost practice tools that's reachable for all higher educations. Recently, there are a variety of automation technology that need to be learned, such as rapid prototyping, machine vision, automated storage and retrieval system, and so many more. This research focuses on developing the automated system learning for material handling and storage, where this activity is needed by almost all kinds of industry. Automated storage and retrieval system is an automated system of storing, retrieving, and moving material activity that is widely used in various industries. ASRS has so many advantages over the manual material handling, such as process accelerations, increased productivity, improved work health and safety, reduced labor costs, increased density and capacity, and increased security. We chose ASRS as our research because ASRS are very common in many industries, very expensive, and also very large. Here is how the ASRS works in general. The machine will store and retrieve the material from specific racks based on the specific command given. The ASRS system consists of several main parts that are storage structure, storage module, SR machine, pickup and deposit stations, and the control system. Until now, the production of most ASRS at this time should be made custom to a few ASRS sellers with very expensive price, large size, and special programming language. This phenomenon makes it difficult for universities to procure ASRS, so that the students can gain practical skills related to the ASRS. Therefore, this research aims to develop low-cost, low-space, and multi-input ASRS for educational purposes in developing countries. Here's the mission statement of our product development. The benefit proposition are low material costs using multi-input, open source programming, modular hardware system, and relatively small dimensions. The primary market is higher education, especially for engineering majors, and the secondary market are industrial training center and high school. This is the flow process of our research method. The research begins with problem identifications, then electrical hardware design, mechanical design, program and algorithm design, implementation and testing, and finish with the conclusion. In our research, there are some simplifications. First, smaller dimensions, then smaller capacity, smaller loads dimensions, open source programming, and more varied input data. Similar with ASRS in general, the movement that occur in the ASRS system based on three axes of linear motions along the x-axis, y-axis, and z-axis. The movement along the x-axis is the positioning movement in the storage rack column. The movement along the y-axis is used to move the ASRS to the appropriate storage rack line or level, and the z-axis is used to position the fork against the specific rack in picking or placing the material. The ASRS uses the Arduino Mega 25 60 microcontroller with RAM's 1.4 silk motor driver that use an open source programming platform with C language that is easy to understand by the students. Here is the electrical hardware design. There are 4 input devices: micro limit switch, keypad, push button, and RFID. There are 3 stepper motors, NEMA 17 as the drive system of the ASRS. There is also 1 LCD display as the human-machine interface. Here's the electrical hardware configurations of the ASRS we developed. The Arduino Mega is connected to the RAM shield. Then almost all components are connected with the RAM shield. Here we have 1 power supply to provide the energy, 2 stepper motor with each stepper driver, 3 and stop sensor to restrict the motor movement on the track, LCD display as the interface, and the keypad, push button, and RFID as the input command components for the system. After that, we designed the mechanism and the hardware of the ASRS. The design ASRS utilized the rotational motion of 3 motors into linear motions. The linear motions mechanism of the x-axis and z-axis motors use a belt pulley mechanism, whereas the y-axis motion mechanism used the less screw. Here's the computer-aided design of the hardware design, along with the dimensions, the power requirement, and the speed of the movement for each axis. Here's the algorithm of ASRS work system as the input of the software programming using Arduino IDE with C language. From the display, we can choose 4 modes to give the command to the ASRS that are pendant mode, coordinate mode, RFID mode, and auto home. When we choose the pendant mode, we can freely move the fork using the push button that can move along the X, Y, or Z axis. When we choose the coordinate mode, we can choose either to make the storing operation or the retrieval operation. If we choose the storing operations, the fork will go to the pickup and deposit station first, pick the load, then go to the intended rack. Otherwise, if we choose the retrieval operations, the fork will go to the intended rack, pick the load, then move the load to the pickup and deposit station. After we choose the operations, we can input the coordinate of the rack with the row number first, then the column number for the second input. When we choose the RFID mode, we have to tap the RFID card that contain the command for the ASRS. The command consists of the operations and the intended rack to pick or to place the material. When we choose the auto home, the fork will back to the default position in front of the pickup and deposit stations. This command aims for emergency situations. After developing all aspects of the ASRS system, we made the prototype of the device along with the manual instruction books for the user to learn the product. Here is the prototype of the product. The cost of making the prototype and the manual book only costs around $200, which can be much reduced if it goes into the mass production stage. This is the video about how the ASRS works when we choose the pendant mode. Next, this is the video about how the ASRS works when we choose the coordinate mode. And this is the video about how the ASRS works when we choose the coordinate mode. Next, we go for the implementation and testing. The final prototype was tested and evaluated for some aspects. First, we test the functionality, usability, and the performance. Testing 5 potential users of the ASRS who are engineering students and lecturers in higher education to carry out tests related to entire use of the design. The tasks are placing and retrieving materials in the unit load from and to 3 different shelves with 3 modes. Before the testing began, the respondents were given manual instructions that were made to facilitate them in operating the SRS. As a result, all the tasks given can be carried out properly and correctly by all participants. The SRS design performance also has 100% correct placement accuracy based on the user input. However, there are some evaluation notes based on the testing. First, the motor speed is considered too slow. Therefore, the motors will be replaced with NEMA 23 stepper motor that is stronger than NEMA 17, so that it will increase the movement speed up to twice. Second, some part of manual instruction is confusing because there's no visualizations. Therefore, some images were added to the instruction manual to make it easier for a user to imagine the instructions manual. For the second testing, we test the ability of the product to educate the user. This test aims to ensure that the SRS design successfully educates its user in terms of practice related to the working mechanism, controller circuit, and the programming of SRS system. The test was held by evaluating the understanding of 5 industrial engineering students who have studied the ISRS design for 120 minutes. The understanding evaluation was held by giving 15 essay questions on understanding the mechanism and how to operate it, the ISRS electronic circuit, and the Arduino programming. As a result, the answer of each respondent were assessed by a lecturer who is an expert in manufacturing, mechatronics, and Arduino programming. The average value of all respondents was 81.33 of 100. These results can be said very satisfactory for us. There are also some evaluation notes based on the testing. First, the students need a guideline book on ISRS programming. Therefore, we have added new part of the manual book that contained the explanation of ISRS programming. Second, the students need a functions to taking or storing material to several syllables at once. Therefore, we have considered it as the further development. Here is the conclusion of our research. The ISRS development research for educational purpose is one effective way to make the automation learning process to be more effective and optimal, especially for developing countries that often experience some financial and space constraints. The developed ISRS only costs about $200 and only need a small space. The ISRS use multi-input command and Arduino open source microcontroller to ensure that the students can learn many things such as work mechanism, operation system, hardware, and programming from this product. By using a similar methodology, subsequent research can also develop other automation learning practice tools with the same background and limitations. Thank you for your attention. Please don't be hesitant to ask me through my email if any. Thank you.